Clayton here, the Algebra Guy. Thanks for tuning in. Our lesson topic, finding trend lines and correlation coefficients. So here are the text that we're going to be covering, 4A and 4C, and both of them require that we use technology. Here's the big idea. Given some data points, like a scatter plot, we need to be able to find an equation that's a best fit line or a trend line for those points, and also be able to do something called a correlation coefficient, and which we'll talk about here in just a second. So let's get to it. So what is a scatter plot? It's a graph of plotted points that may show a relationship between two sets of data, kind of like this right here. So a professor was curious if age had any relationship to do with the final exam score, so he plotted the points. He took a person's age and plotted their score, took their age, plotted their score, and here's the graph that he came up with. He's trying to understand, is there a relationship? And if so, can he make a prediction given a trend line or a best fit line? So notice that this graph does not have a linear relationship, because if it did, the points will line up in such a way as to make somewhat of a line, but there is not one here. In other words, there does not appear to be a relationship between the age of the students and the final exam score, which we would expect, right? Now, if you would have plotted the final exam score versus the number of minutes or hours someone studied, then there probably is a correlation between the two, but age and score, not so much. All right, look at this table. This table shows the number of cricket chirps in 15 seconds for several different air temperatures in degrees Fahrenheit. Plot this data and determine whether the data appears to be linearly related. So we're going to be using our calculator quite a bit. I'm going to take our calculator out so we can plot these points and see what the relationship is, or if there is a linear relationship. And then we're going to ask the question, what is the trend line if there's a relationship, and the correlation coefficient. So let me take the calculator out, and I would encourage you to do the same. All right, so let's go. In order to plot these points, I want us to go to this listen spreadsheets, and here I'm going to type in my titles. So I got chirps and we got temperature, and all I'm going to do is key in exactly the figures that they have here. So I'm gonna go 44. All right, that should do it. So now that I have these two in here, we can check to see if indeed it looks like a line. How can we do that? Well, there's a few ways. One, you could go back to your home screen and click on the list. Let's see, what is that? This button here, the data and statistics. Or actually from the place we just came from this spreadsheets area, we can actually do that from here by clicking on menu and statistics. So when we do that, or data, I'm sorry, and we can get a quick graph of what this looks like. So we'll click here on the left side. This left side is going to represent our y-axis, which is our temperature, and the x is our chirps. And if we look at it, you can tell that they generally look like a line. Let me make it a little bit easier to see and pull that over. So you can see that it looks like a line. So the answer to the first question is yes, they do. They are linearly related. So what is our next question? So this is how the graph look if you were to graph it, if I were to take a picture of it. So let's find the trend line for this data and make a prediction asking what would the temperature be if there was 60 cricket chirps. So what can we assume the temperature to be if 60 cricket chirps? So we can see up to about 40, 44, but what if there was 60? So let's try to see if we can make some kind of prediction. But first, let's draw a trend line. Well, how do we do that? Well, I'm going to go to menu, analyze this graph, regression, and I'm going to show a linear line. Now they're asking, do I want an mx plus b or a plus bx? Mx plus b is slope-intercept form, which we're more familiar with. So I'm going to use that one. So when I press that, there it is. They draw a line that's the best fit line. So look, that's wonderful because we don't have to try to guess and sketch out a line. They're telling us from the data you've given us, this is the best fit equation. So what equation is this? Let me write it here. So it looks like if I were to sum up this, let me put it over here. So if I were to sum this up, it looks like y equals 1.14, and now I'm estimating, because it's a trend line, it's a best fit line. You don't have to write all those digits. Maybe I'll go one more digit. So 1.143 x plus, here's my y-intercept, 30.28. So I'll stop there since I have 0.280. So there's a best fit equation that I could use. Now, there's a couple of ways you can use that equation to figure out the answer to this next question, which is what prediction can be made about the temperature if there were 60 cricket chirps. So 60 cricket chirps, the chirps are corresponding to my x value. So I could just plug in 60 right here, multiply by 1.143, add 30.28, and there I have my answer. So you can put this equation back into your graph, go to your graph, and now I don't want to do this, that's why I'm not doing it. I don't, actually, you know what, let's do that. I don't want to do that, but it won't take but a second. So let's put this back in here, 1.143 x plus 30.28. So I press enter, so that line is already here, and if you wanted to see it, we could zoom in. Let's see if we can find it with a fit. So there's a line right here if you needed to see it. Now we don't necessarily need to see it. What we want to know is what's the value of y, the temperature, when x is 60. So I've shown you how to work that a couple of different ways before. One way is to trace the graph. So if I do a graph trace and I type in my x value that I'm looking for, which in this case is 60. So I type in 60 like that, it automatically comes up x equals 60, and I'm going to press enter. So look, it's telling me that it's about 98.86. So there's my answer. So they're telling me that it's going to be 98.86 degrees. Looks at Fahrenheit, I believe we're looking at. Yeah, I think it's, yeah, there it is, Fahrenheit. So degrees Fahrenheit. So there, we're done. It's that simple. Now I wanted to go back and show you another way we could have done that. Let's see if I can get back there. So another way we could have done that is from this screen, we could have traced the graph as well. Now I didn't find this out until recently, that I can trace it from here to get a pretty good idea. So let's see if I can find that here. So go to Analyze and Graph Trace. And now look what happens is as I go along the line, it's telling me all the points, all the values. I see that 33 is about 68. I go up here, it's 40 degrees, or 40 chirps is about 77 degrees, and I can keep moving. Matter of fact, if I press my cursor arrow to keep going up, it'll keep going up as well. Look at that. So I can actually estimate and do everything right here from this place. Now I've already passed my 60, so let me go back to about 60. And this is about as close as it's going to get. If I want to get closer, I could just hover over with my cursor and get to 60. If I press click, it'll actually leave that point there. So now I can see that this is 98.89. We got 98.86, but 0.03 of a degree off is not going to make a difference here, especially because you're going to be given multiple choice. So those are a couple of ways you can use to make predictions given a table as you see here. All right, let's go on to our next question. All right, now what if I asked you to find the correlation coefficient? Well, what is that? First of all, before I can find it, well, correlation coefficient is a value R, we're going to call R, that's called R, not just we call it R, between -1 and 1. What this value is doing is trying to understand the relationship between your data. How closely connected are the chirps to the temperature? How closely is the relationship between those two? If the number is greater than 0, it's suggesting that it's positive. In this case, like it's going up. And we can tell that this was going to be positive because it's going up. Has a positive slope. 0 means there's a negative relationship. The closer the value is to 0, the more scattered the data. So you have points everywhere. So let me go back down here. Uh-oh. I want to go back there. So let me go back to my graph. So if I went down on my graph, so we're looking at our points here, we're asking ourselves, how scattered are the points from this trend line? The closer the value is to 1 or -1, the less scattered the data is. So here's some examples. If it were 1, all these points right here are pretty close together. They look just like one unified line. But as we get away from 1, look what happens to the points. The scatter plot, it gets thicker and more of a cloud. 0.4 and now 0. See, there's no relationship here. It's just a big blob. And as we go negative, it starts to have a decrease in relationship, like a decrease in slope. So what is our correlation coefficient and how do we find it? So let's see if we can find it here. Actually, I give it there. I don't want to go there just yet. So how do we find a correlation coefficient? The cool thing is that you already have a lot of the work in front of you if you put this in your calculator already. So what I'm going to do is go back to my calculator screen. I'm going to move this back over here and go and click back on my table. And here are some options that I'm given. I can now go to Menu, Statistics, and after I go to Statistics, I can go to Stat Calculations and Linear Regression. So it's the same thing idea what we just did. When graphing the line, we look for the regression line. We're going to go back to the regression line and we're going to click here. So now they're asking, what should we put in column C? We're going to put a lot of information in column C. So I want them to put in X column my X values, which were the number of chirps, and Y, we're going to use the temperature, and I'm going to leave everything else alone. So let's not worry about any of these other parts. So we're going to press OK, and I'm going to move this over, and let's look at what we're given. So if I look at my table, look at what we're given. So they give us a title, the regression line mx plus b. They actually tell us right here what our slope is, the m. Look at that, 1.143. So we actually could have just used this to come up with the equation. The y-intercept is 30.28. This is all the answers we just got. And look at the one we're looking for right here. The R value is 0.95. That's really close to 1. And if you look over here at what we just discussed, really close to 1 means that there's a very close relationship between those two variables, the temperature and the chirps. So 0.95092. So that's what I talked about here. Go to Menu, Statistics, Stat Calculations, Linear Regression, and you end up getting 0.9509 as your R value or your correlation coefficient. All right, so let's do some practice. Let me erase my screen and we'll practice this one. I want you to put this one in your calculator as a table. Find the best trend line and the R value from what we just discussed. All right, I erased my table, and again, work this problem. You want to erase yours too. If you have trouble doing so, go to Document, File, and do New Document. Do you want to save? No, and that way you get a fresh screen. I'm gonna go back to my list and spreadsheets. So this problem says gasoline consumption in the United States have been steadily increasing. Consumption data from 94 to 2004 is shown in the table below. Determine whether the trend line is linear, and if so, find a model for the data. Use the model to predict the consumption in 2008. So let's make a prediction what the consumption would be in 2008 from this table. So in order to do that, let's first set it up by putting our information, our X and Y axis, our year and our consumption. All right, so now we have the years 94 through 2004 here. Now you want to be careful because here's can be a challenge. You want to put 94, 95, 96 in there, right? But really we should be putting how many years from 94 are in each column. For instance, in 1994, how many years away from 94 are we? Well, we're 0 years. Well, 95, how many years away from 94 are we? We're 1 year. So it's a lot easier for us to calculate than trying to start at an X value of 94, and the data is going to be a lot more accurate. So you normally want to start this way. If they're starting at 1994 or a big number like this, especially with time or years, start with 0 as your starting place and count up to where we need to go. So this is going to be, it looks like a 10-year spread from 94 to 2004. So I'm just going to continue going 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So it's 11. So we're going to go all the way to 11 here. All right, sorry, I just realized there's 0 to 10, not 11, because we counted to 0, so that would be 11. So I got all my data in here, as well as my titles, my X and Y axis titles. Now, what are we looking for? We're looking for a trend line, and we're going to look for the correlation coefficient. Now, we found a way to do both, right? In pretty much one step. So the way we did that, we went to Menu, Statistics, Stat Calculations, Linear Regression, and then we told the calculator what our X and Y axis is. So the X was the year, the Y is the consumption, and we pressed enter. And when we did that, we were able to see, let's scroll up here, we got that title, the MX plus B. Here's our slope. So if I were to write this out, so I know my equation is, my slope is 2.2 2.2090. It just keeps on going. So I'm saying 2.209 x, and then we can look back over at our y-intercept of 113. So I'm going to write that plus 113. 113.318. 113.318. So that equation is the best fit line, or the trend line, that you'll want to select. Oftentimes you may just have this as a multiple choice answer, so you'll have different given equations, and that's the one you'll want to pick there. What about the R value? So don't pick the R squared value, because you notice that that number is there, but we don't want the R squared value. That's something else that we're not dealing with here. We want this R value. The R value here is 0.99653. So we'll write that down. R is going to be 0.99653. Pretty easy. Now we could have graphed it and visually saw it, but we just didn't need to. We just wanted the equation and the R value, and we got it. So these are pretty closely related. I mean, it's almost one. That's like a very close relationship between the consumption of, what is this, gas, and the year. So we can have conversations around that. But the big thing is we know how to find those answers. So let's go to our next problem. All right, this now brings us to star. What does it look like on the star questions? So here's our first one. The scatter plot shows the monthly high temperatures for Austin in degrees Fahrenheit over a 12-month period. Which function best models the data from month 1 to month 9? It doesn't look like I'm going to need a calculator for this one, because they pretty much gave me everything right here. So I'm going to go and make this a little bigger so we can see it. All right, so you have to be careful reading this one from month 1 to 9. So from month 1 to 9, so we're not even caring about these points at all. Now, if you wanted to, you could take every one of these points and put them in the table and find the best fit line. That would be pretty easy to do. But you can also just estimate, right? So if I just estimated a line, I would say there's a line, a best fit line, going through about like that. So that looks pretty good, right? The points on each side, that looks a pretty good average line. So with just that line, I can already conclude what the answer is not. Well, the fact that the line is going up tells me there's what kind of slope? Positive. So I'm looking at F equals, where F is Y equals negative 1.6. Well, it's not going down. That's clear. J is not going down. So that's clear as well. Now I have two others, J, G, and H. So they have very close slopes, which is hard to tell here, but the y-intercept is 85 to 90. Now there's a big difference on here. if you notice, a y-intercept here of 85 is there, of 90 is here. Now it looks like I could have drawn my line better. So maybe they're right there. So I could have drawn my line better to go hit through here and be about 90. So it becomes pretty clear that 90 is a much better y-intercept than what it's a little better y-intercept than I originally had, but it's a much better y-intercept than 85. Surely we're not going through 85. There's no points even in between if I were to draw a line here. So if I try to draw a line here, it just wouldn't go through here correctly. So you want it to be evenly going through those, and it's not happening there with 85. And I could take some points again and get the slope and the y-intercept, but it becomes pretty clear just from eyeballing this that my answer is going to be H. Now most students do get this one right, so I expect you to do so as well, especially with the tools that we've just talked about, that you could go the extra mile and place those points in the table and get the exact best fit line, and you'll see that the answer does reflect H better than it does G. So let's go to our next problem. Population of Webb County, Texas from 2000 through 2010 is shown on the graph. If the trend shown in the graph continues, what will be the population of Webb County in 2015? So we're making a prediction now given this data. Now notice that as we discussed before, although they're talking about 2000 to 2010, they don't put 2000 here. They just start at year 0. They start counting from number of years since 2000, as we discussed earlier. There's 2 points that they've given us. So this one actually is pretty simple because they gave us 2 solid points. Well, by giving us 2 solid points, we have a definite line. And when I have a definite line, I can find the equation of that line and find every points for the future. So I can find future points on the line. So we're looking for at 2015. So I'm really going to be looking for what is y when x is 15. So I can kind of put a line up here, and I'm curious where it's going to cross. So is that about let's see, this is about 12, 14. It's probably a little bit further out, but somewhere right there. Now you could kind of guess and eyeball that, but I wouldn't do that for this one because it becomes tough when you're trying to redraw the graph. I would definitely use my calculator to solve this one by placing these 2 points, find the equation for the line for these 2 points, and just simply figuring out what the population is at 15. So let's do that. I'm going to bring out my calculator again, and I'm going to put these points in my spreadsheet. So we're going to call this years and population. Now you could just say X and Y, but I'm being a little bit fancy. So population. My years are 0 and 10. And for 0 years, there's 193. And we're talking about thousands, but I'm not going to write thousands there. You know what? Why not? I'm on the calculator. 193,000. And 250,000. So you don't have to write thousands here. They wrote just 250, but since we're in the calculator can handle thousands. You'll just have to remember that we're dealing with thousands, which is not a problem because we have multiple choice, all in thousands. So I'm gonna press enter, and I want to find the point where at 15 years later, what the population is going to be. So I'm going to ask this to draw a graph. We're going to go to menu, statistics, or no, data. Yeah, the data, we're going to go quick graph. I see those 2 points there. My population is my Y. My years is the X. I'm going to pull this over so we can see it better. I want a regression line that connects those two so I can figure out what's going to happen in year 15. So to get that regression line, I'm going to go menu, analyze, regression, linear, and I get that line there. So this is great. Now I can press menu and analyze this graph. Let's trace this graph, and we're going to follow this line all the way up to where it says right here is 10, but we want to follow it all the way up to what? 15. So at 15, let's see what's happening. Let me move this over. So at 15, we're at 16. So at 15, that's about pretty close we're going to get. We're at 278,000 and something. Now we look at our answer choices, and there is nothing else even close to that. So it becomes really clear that that's our answer, and we can feel great about it. We put all our numbers in the calculator, and it's just very clear. All right, and that's all we need for that one, 278,000. Let's go to our next problem. All right, our last problem from the start is this table here. They're asking for correlation coefficient. So what does a correlation coefficient for the data indicate about the strength of the linear association between the height and the length of these rectangles? So is it a strong relationship, weak relationship, positive or negative? So to figure that out, you could just put all these points into your table, see if it's going up and down. If it's increasing slope, well, we know it's positive. If it's decreasing, it's negative. But what about the strength? Is it weak, strong, or otherwise? Well, it's going to be weak or strong. So, because that's the only two options. So let's put this in the calculator. I'm going to go to my list and spreadsheets, and we're going to put all this in. So we'll make our height the first one, and our length the second. And it doesn't matter the order here, but we'll put them in just the way we saw it. All right, so let's put all our numbers in. 41. And our length. All right, so we got everything in there. We could go back and double check to make sure all these points are corresponding with what we see on our screen, because if we're going to mess up anywhere, it's probably there. So I'm just kind of perusing over everything and make sure that I put all the points in correctly, and they look good. Now, if these points were in order, we could have easily seen if it's decreasing or increasing, or done like a slope test. And you may be able to just do that now, but since we have the power of this calculator, let's use that. We want to take these points, and instead of putting them on a graph, we want the R value. So since we want the R value, we're going to go straight to Menu, Statistics, Stat Calculations, and Linear Regression this way. Our X value we had in there for Y, height, and our Y we had length. I'm going to press OK. And we're given the equation, which is really cool. I get excited about that. But we really want the R value. So the R value is right here. I shouldn't have clicked on it. So the R value is right here at 0.15. So let me write that down. So our R value is 0.15548. Now that's all we need to answer this question, or it should be. Because remember, if it's positive, that means it's, well, if it's increasing, if it's above 0, that means it's a positive correlation. So weak, negative, it's not negative. It's not negative, so we know it's not A and B. And the closer it is to 1 or -1, the stronger the relationship. The closer the number is to 0, the weaker the relationship. Which is this one? Is this 0.1 closer to 0 or closer to 1? Well, it's a lot closer to 0, right? Because it's only 0.1, a tenth away from 0, and 0.9 away from 1. So, because if I put it on the number line, you can see it pretty easily that, 1's here and 0.1's here. So this thing's really close to 0, making it a weak relationship. It's a positive relationship, but it's a weak positive relationship. So no need to guess on that one. Some students tend to guess or kind of get it started with the slope, but not sure about the weak and strong. Now we know that the calculator can handle that with just a few clicks. So let's handle it that way. All right, I think this brings us to the end of our lesson. Now we know how to calculate the trend line using the calculator. We know how to estimate just from eyeballing it, given some points on a graph. But we also know how to find the R, the correlation coefficient, and understand the strength, positive, negative, or weak or strong. Hey guys, thanks for tuning in. My name is Brandon Clayton, the Algebra Guy, and I will see you next lesson.